Alright, so here we're going to be looking at this idea of boiling and evaporation. I'll start off with this idea of boiling, where we're looking at that it's a phase change of a liquid into a gas that occurs at a fixed temperature. For water at standard pressure, it occurs at 100 degrees Celsius. Although can be changed. If we place it at a higher pressure than atmospheric pressure, it will increase this boiling point, and if we lower the atmospheric pressure, it will decrease the temperature at which this occurs. And basically it will occur when the vapor pressure of the liquid equals the atmospheric pressure. Now, this boiling occurs right the way through the liquid, and you can see there are bubbles that are forming. It's taking place right the way through the liquid. It occurs at a fixed temperature, and the temperature remains constant. So the temperature remains constant with that. Now, evaporation is also going from a liquid into a gas, but it's only certain molecules. It's not the whole liquid that's changing. And here the definition is when faster moving molecules have enough energy to escape from the surface of a liquid at a temperature less than the boiling point, leaving slower moving particles behind, which result in a cooling of the liquid. So this happens at the surface, and it happens at a temperature below the boiling point. Now, I'd just like to use a simulation just to explain this idea. Here I've got one of the FET applications, and I'm going to put some gas into it here. You can see there's a certain pressure that's there, and there's a certain temperature. It's at 300 degrees, 300 Kelvin. I'm going to add some heat. I'm going to make a temperature a little bit higher. Now, as you can see in here, you have got particles that some of them are moving faster, some of them are moving slow. But this temperature over here, this temperature is giving an idea of the average kinetic energy of those particles. Now, what happens if I allow some to escape? Some of them escape like that. Now, watch the temperature. Can you see the temperature dropping over here? And when I close it, the temperature is much lower. Now, why is that? Well, when you actually have a look at the particles, you'll see that overall they tend to be moving slower. They're moving slower now overall. The faster ones, the ones with the higher kinetic energy, the ones with the high KE or EK, kinetic energy, have escaped, leaving the slow ones behind. And so the average kinetic energy, of the molecules has gone down, has decreased, and therefore the temperature has decreased. And that's the idea with evaporation. When you feel the coolness of evaporation, it is because the faster moving molecules escape. They are the ones that can break the intermolecular bonds. They escape, leaving the cooler ones or the slower moving ones behind, which is indicated by this idea of coolness. Okay, so good. So I hope it explains that reasonably clearly. Going on to this idea now of specific latent heat. We've discussed it a bit, but that is the energy per mass absorbed or released during a phase change. Now, this energy comes from a change in the potential energy. So when you're going from, for instance, a liquid to a gas, we have to add energy into the liquid to make it into a gas, because the potential energy of the gas is higher than the liquid. Now, the formula that is given for is the heat is equal to mL, where L is a specific latent heat. And this is a value that you would get from a table. These are values that you can find. They have been determined for all liquids. It's the same when you're going from a solid to a liquid, or vice versa. Heat is either, when it's coming this way, when I'm going this way, you're getting heat is given out, all right, because the solid has got a lower potential energy than the liquid. And if I was going in this direction that way, you would have heat needs to be put into the system because it's got the potential energy is higher. Okay, and I have done some examples of that in the of using this formula, Q is equal to ml. I hope that seems fine. Thank you very much.